Welcome to solverfy.
The answer to chapter 27, problem number 37 from the Smith Organic Chemistry textbook. We're asked several things in this problem. We're asked what type of cycloaddition occurs in reaction 1. We're asked to draw the product of a similar process for reaction 2. And we are asked whether we would predict that these reactions occur under thermal or photochemical conditions. Okay, so looking at reaction 1, we're not asked to draw the mechanism, but for these cycloadditions, it is often helpful to draw the mechanism. And so that is going to look like this. So the electrons are moving this way in a circle. Okay, and so that's how we get to the product. Okay, so we have 3 pi bonds. Reacting with 2 pi bonds. And so what we actually have here is a 6 plus 4 cycloaddition. Because remember, each pi bond is going to have 2 electrons in it. So 6 plus 4 cycloaddition would be the type of cycloaddition. The similar process for reaction number 2 would give us a product that looks like this. And just bear with me while I draw it. Oh. Okay. Something. Nope. Sorry. These are pretty difficult to draw. Okay, so there we go. Double bonds here and here, as well as here. We would still have our ketone in place here. We would have a methyl group here, and another methyl group here, as well as that. Okay. And then, of course, the 2 benzene rings. Okay, so that is going to be our product for reaction 2. And so we are forming 2 new sigma bonds. And so I'm going to move what I wrote before just so that I have space for everything. So we're forming 2 new sigma bonds on the same side. Oops. And so that makes this a suprafacial cycloaddition? And so since this is superfacial and 5 pi bonds are taking part in it, we know that from the table in this chapter, this must proceed under thermal conditions. So that's the answer to the third part of this question, thermal conditions. So the first answer is that it's going to be a 6+4 cycloaddition. I've drawn the product to reaction 2, which was the second part of this problem. And then once we determine that it is a superfacial reaction and that there are 5 pi bonds taking part, we know from the tables that this has to be under thermal conditions. Okay, and so that is the answer to chapter 27, problem number 37.